So let's take a look at number 5 here. Given this graph, let's answer the questions. All right, so we have this graph, and let me just go to the question for a minute. At what x value or values is f of x not differentiable? Okay, so, well, we know that if we have a discontinuity, like we have at 1 and like we have at 3, well, it can't be differentiable if it's discontinuous. Then we also know that if we have something like a cusp right there, or actually that's more of a sharp corner, so right here at 5, that's also going to be a not differentiable point. So 1, 3, and 5. All right, at what values, x values, is f of x continuous but not differentiable? Well, that's if we go back to here at 5, it's continuous but not differentiable. All right. And now, at what x value or values is f of x, f prime of x equals 0? So when is the derivative equal to 0? So if we go back to the graph here, derivative of 0 means horizontal tangent line. So if I look at this graph, I think about here at -1 looks like we would have a horizontal tangent line. And so that's the place there. Okay. Logarithmic differentiation. Okay, so use logarithmic differentiation to find dy dx given this function here. Okay, so I'm going to rewrite this as x plus 1 to the 10th over 2x plus 1 to the 5th all to the 1/2 power. And so the whole idea with logarithmic differentiation is if we apply ln to both sides, let's see what we get. All right, so what we're going to do before any derivative taking with these ln's now is we can do a lot of algebraic simplification. So the left side is still just going to be ln y, but on the right side we can bring that 1/2 down, and then we have ln of a quotient. So that would be ln of x plus 1 to the 10th minus ln 2x plus 1 to the 5th. And now inside the brackets there we have more opportunities to do some algebraic simplification. So 10 ln x plus 1 minus 5 ln 2x plus 1. Okay, so right now that looks about as simple as we can get it by doing the algebraic simplifications. And now I'm going to take derivatives. So none of that to this point was derivatives. Now, I'm going to take derivatives, but I have to do this implicitly. So I'm going to be doing the derivative with respect to x of each side here. Let me just set that up. Okay, and so on the left-hand side, the derivative with respect to x of ln y is 1 over y, and then dy dx. All right, on the right-hand side, we get a 1/2, and then we go inside, so then the derivative of 10 ln x plus 1 is 10 times 1 over x plus 1 times the chain rule factor of 1 minus 5 ln of 2x plus 1, 1 over 2x plus 1 times a chain rule factor of 2. All right, so let's clean this up a bit. 1 over y dy dx is, now I could multiply this 1/2 in, because it's going to reduce with the 10 and cancel out the 2. So I'm going to get 5 over x plus 1 minus 5 over 2x plus 1 after the 1/2 reduces with the 10 and cancels the 2 over there. Okay, so now the last thing I need to do is I need to get this y to the other side, and the truth is I could factor out a 5 here. So I have a 5, the y, 1 over x plus 1 minus 1 over 2x plus 1. And the last thing to do in one of these logarithmic differentiations is notice that right here I have y, but I know what y is from the beginning of the problem. Okay, so I'm going to put that back in. So 5, I can use either notation, x plus 1 tenth over 2x plus 1 to the 5th times the 1 over x plus 1 minus 1 over 2x plus 1. And there it is. There's your dy dx. Okay, so I hope those problems provided a little review with me working around the problems. So hopefully that was helpful.